And today on how it's made.
DNA!
Before we begin making the DNA, you want to know what it's made of. So there's three parts to a nucleotide. The sugar, the phosphate group, and the nitrogenous base. There are 4 different nitrogenous bases.
Right, so we have our A,
Adenine,
our T,
thymine,
our C, cytosine, and our G, guanine. It's also important to note that at the start we are doing the leading strand, which is in the 5 to 3 prime direction, and later in the video we will be doing the lagging strand, which is in the 3 to 5 direction.
but we still build from 5 to 3. Okay, just keep in mind that the leading and lagging strand happens at the same time, but we'll be showing you them at separate times to simplify it for you. Okay, so the DNA, making it, it's semi-conservative, so only 1/2 of the DNA strand is actually new, brand new, and the other side is a parental strand. And this all happens in the nucleus during interphase.
Alright, so let's begin. It's important to know there are 7 major tools in making DNA.
Yes.
The first is primase.
Primase attaches the primers onto the DNA strand. Helicase.
Helicase breaks the hydrogen bonds between the bases. DNA polymerase 1.
DNA polymerase 1 substitutes the primers into base pairs.
DNA polymerase 3 adds the base pairs to the strand. And DNA ligase.
Ligase acts as a glue to bind the new daughter strands together. Gyrase.
Gyrase stops the DNA from tangling up.
Yeah.
And the single-stranded binding protein.
The single-strand binding protein is a great tool. It stops the DNA strand from reannealing. And there you have it, all your tools. Okay, so before we begin, I just want to point out that we have already untwisted the DNA, just to make it easier to work.
It's an easy process. You guys don't need to see that. So, first, helicase comes in, and it breaks the bonds between the bases.
Knocks the living daylights out of that baby.
Really
Okay.
does.
Then comes our wonderful friend Gyrase, and look what happened! It's tangled! What are we gonna do? It's okay, Gyrase is coming. Save the day.
Look at Gyrase saving the day like never before.
But you've never been saved by Gyrase.
Actually, every day. Right, so our single-stranded binding protein travels up through the newly separated bases to stop them from reannealing.
Then we have the enzyme, the primase. It is the first tool that actually builds something. It lays down a primer to the first parental base, and this is how the polymerase 3 knows where to begin. But as you can see, the base pairs do not correspond. Now that DNA polymerase 3 knows where it can start, it lays down a base pair that corresponds, so is opposite of this one. Just like that.
Whoa!
What, you're surprised?
Repeat this process until you reach the end of your replication fork. Don't forget to replace the primer with its corresponding base using DNA polymerase 1.
Now we're going to build the lagging strand. The lagging strand needs to be, just like the leading strand, replicated in the 5 to 3 bind direction. but it is in 3 to 5. So we need to lay down some primers with primates. Ta-da!
While bases are being added down there, Primase adds 3 more primers at the start of the replication. Once again, polymerase has a good starting off point and can work its magic.
Using polymerase 1, swap out the primers for the corresponding base pairs. Then, use ligase to glue them together. Congratulations! We have now made 2 new daughter strands. We've made our very own DNA.